Hey guys, this is Mr. C, and in this video, we're going to be talking about some compound inequalities. So a compound inequality is an inequality that has more than one inequality in it. So as we see this first example here, it says x minus 3 greater than 1 or x plus 2 greater than or equal to negative 6. So all of these are different. I'm going to show you the general solution process, but these can kind of look like anything here. So just kind of expect that when you get problems from your teacher or professor. So what you normally do is you take each of the inequalities, and these are actually pretty simple, and you solve them one at a time. So there's number one, there's number two. And so number one is x minus 3 greater than 1. So if we were to solve that, you just add 3 to both sides, and you would get x greater than 4. For the second one, you got x plus 2, and that's greater than or equal to negative 6. And these symbols can flip left or right, less than, greater than, equal to, not equal to, strict, not strict. So these can look like anything too. So don't think that they're all going to look just like this. Okay, there are ways to change these things up to make it look different. Subtract 2, and x is greater than or equal to negative 8. All right, now what you normally do is you want to go ahead and graph the solution set to see what that looks like. And so when you graph the solution set of the whole thing, you need 3 number lines. So here's one, and I'm gonna leave some room. Here's the second one, and here's the third one. All right, so before you start writing down your solution set, it helps tremendously to have a picture of what's going on. All right, so what I'm going to do is I'm going to graph the first one here, the second one here, and then this one is going to be the final one. Okay, so final. All right, so the first one is all real numbers greater than 4. Okay, now over here I've got a negative 8. So what I really want to do here is I want to kind of accommodate both of these on all 3 of these number lines. So I'm going to put the 4 a little bit over here on this side, okay? For the second one, I'll put the negative 8 over here to the left of it. So for this one, I'm going to have an open circle, and it's going to be shaded to the right. Okay? For the second one, I've got a negative 8 sitting over here. It's a closed circle, and it's shaded to the right. Okay, so all of that's going to keep going. And then what you have to do is you have to analyze both of these number lines and the word up here that says or. So, or means either or. A number for x can be a solution for this one, or it can be a solution for this one. Either one will be okay. It does not have to be both of them at the same time, because or implies that this could be a true statement, or this one could. So one of them could be false. The only thing you don't want to happen is both of them to be false. One of them at least has to be true. All right, so if we look at these 2 number lines, it looks like any number less than negative 8 for a value of x is not going to work for either of them, right? And you can plug in those numbers in here just to be sure if you want to. It looks like negative 8 starts for this one, and it keeps going forward, and it actually passes over this one right here. So from negative 8 to 4, you get no solutions for this one. But from here and here, you get both of them. But the word or sits there, and the word or means I could have either one of these be true. So which one has the maximum amount of solutions for me? It happens to be this one right here, because this one overlaps this one. So my final number line would be negative 8 with a closed circle and shaded to the right. And the reason why is because it's an or. And this is going to be confusing probably for somebody who's seen this for the first time for maybe a while. But this is how it works. So you might want to review this video a few times. So how would I write that as a solution set? Well, here's what you would write. All x, all real number x, that line means such that x is, and it has to match this graph right here, greater than or equal to negative 8 and then close your curly bracket right there. So that's what the graph would look like. That's what the solution set would look like for the entire problem there. All right, so let's take a look at this one. Okay, this one has a different word in there. This one has the word and in there. So we're gonna probably have something different going on. All right, so you got number 1, you got number 2. All right, let's take a look at these two guys. 2x plus 1 greater than -5. Subtract 1, subtract 1. 2x greater than -6. Divide by 2. And it looks like we got x greater than, what, -3? All right, let's take a look at our second one. Our second one is 3x greater than or equal to 12. That's just one step. Divide by 3. And then it looks like you got x greater than or equal to 4. All right, let's take a look and see what this one looks like. So here, we're gonna have 3 number lines again, and I might as well just put them down here. That's fine. 1, 2, and 3 for our final. Okay, so we got number 1, number 2, and then final. All right, so let's start with number 1. -3, right? All real numbers greater than -3. So here's -3, open circle, strict inequality, shaded to the right. We'll go all the way over. Okay, number 2. 4, closed circle, all real numbers greater than. Okay, final. Now, the word and up there. The word and means whatever values for x that you decide that you're going to keep for your final solution set have to satisfy both of these at the same time. Not one or the other, both. So as I look at my 2 number lines, I see 4 on forward are going to be those numbers that satisfy both these at the same time. In between here and here, it's only the first one. And back from -3 on back, it's really neither. So what I want for my final 4, closed circle, because that's a closed circle and that's covering it right there, and then shaded to the right. Okay, now how do I write that as a solution set? All real numbers x, such that x is greater than or equal to 4, and then curly bracket. All right, let's take a look at another one. Okay, here's another one. This one says or for this one. So let's see how this is going to work. We've got number 1 there. We've got number 2 there. So number 1, 4x minus 3 less than 5. Okay, let's add 3. 4x less than 8. Divide by 4. And so x is less than 2. All right, second one, 2x less than or equal to -6. Divide by 2. Cancel that out. And we get x is less than or equal to -3. All right, here's the 3 number lines. Leave some room there. Okay, and you see now why the pictures help so much. 1, 2, and final. All right, for our first one, we've got all x less than 2. Okay, so here's 2 over here. Open circle, because it's a strict inequality, shaded to the left. So let's shade all the way over like that. Okay, second one, all x less than or equal to -3. Closed circle, shaded to the left. All right, final. Okay, we have the word or. Critical that we look at these. Okay, since we have the word or, either one of these, the solution sets will work for the entire thing. It can be a solution of this, or it can be a solution of this. And what I mean is, even though this one for number 2 does not contain solutions for the first one, it's still okay, because even though these numbers will fail, such as 0, will fail in the second one, they will not fail in the first one. And so therefore, we need to take everything from 2 on back. So our solution set is going to be an open circle at 2 on back. All right. Now, what is that going to look like as a solution set in set builder notation? All real numbers x such that x is strictly less than 2. X strictly less than 2. Close it up, and we are done with that one. Again, these can look like anything. Sometimes they look like this. Sometimes they go apart from each other. Sometimes they both go in the same direction. Sometimes they go in the same direction this way. Sometimes there's open circles. Sometimes there's closed circles. You just have to take each one, do the process, think through it, analyze it, and you should get the correct graph and the correct set builder notation for your final answer. All right. Now, here's another compound inequality. This one is interesting because it's 2 in 1. You have this one, x plus 2 less than or equal to 3, and you have this one, -4 less than x plus 2. You could actually take this and split it up into 2 inequalities like this if you want to, but there is an easier way to do this. The easier way to do this is to, let me get a marker here, take the inside and unwrap everything, and then finally get the inside with just an x in it. So here's what I mean by that. Take the x plus 2 and subtract 2 from all 3 parts of this. All 3 parts. -4 take away 2 is -6, less than, those cancel out, x less than or equal to 3 minus 2 is 1. Okay, this is going to be very, very easy to graph. This is your solution set, basically. This is it. So if you want to write this in set builder notation, simple. Such that all real x, and then you just put a couple curly brackets in there. That's done. If you want to graph the solution set, which is very frequent, you have to do that. No problem. -6, 1. This means all numbers, real numbers between -6 and 1, but not including -6. So open circle here, close circle there, and then you just shade the middle part. And that's how you solve those. All right, let's do another one of those. Okay, here's one. Okay, so let's get a different marker here. Let's try this one. All right. So here, the inside part here, the middle part's a little bit more complicated. Again, you could treat it as 2 different inequalities if you wanted to, and then put them back together at the end. I would rather just do this. +3, +3, +3. Cancel those 2 guys. 5 plus 3 is 8. Less than or equal to 2x. Less than or equal to 20. All right. Now just divide everything by 2. 8 divided by 2 is 4. Less than or equal to x. Less than or equal to 10. Again, that right there is in set builder notation. Well, ready to be put in set builder notation. Just put these little pieces together, and now it is. Now it's done. All right, if you want to graph it, the graph isn't really going to be too difficult. Let's go ahead and graph that, because some students do struggle with the graphs. Okay, here's 4, here's 10, and it's going to be all real numbers in between 4 and 10 and including 4 and 10, because you got the little equals parts there. So close circle, and then you're going to shade the middle part. And that one's done. So not too difficult. Finally, we got our last one here. Okay, this one, we're going to do the exact same process we did before. We're going to first, subtract 6 from everything. Negative 6 minus 3 is negative 9, less than or equal to 2x. Those cancel. 12 minus 6 is 6, less than or equal to in there. Now divide everything by 2, and we get negative 9 halves, less than or equal to x, less than or equal to 3. All right, again, really easy to go ahead and do your set builder notation. So put your such that line in there, all real x, curly bracket, curly bracket. Okay, now for your number line. Okay, let's go ahead and do that. I like to use a lot of colors. Okay, so we've got negative 9 halves on here somewhere. Don't freak out because it's a fraction, it's no big deal. Got a 3 here. Okay, all real numbers in between negative 9 halves and 3, and including negative 9 halves and 3. So we've got 2 closed circles, and we're going to shade the middle part just like that. And we're going to make all our teachers and professors happy because that is it. So compound inequality is not too bad. Just be careful. You can change these up with the signs and with the numbers. But just follow the process and you guys should be okay. Remember to like and share. Subscribe to my channel if you haven't already. I'm going to have many more videos out soon. And we'll see you guys soon. Bye.